Very good. So some of you asked to solve the following problem. Find the area of a surface obtained by rotating the curve, this curve that we have, which is defined using theta, which is a parameter for you, about x-axis. And we don't have any issue with the formula. The formula for surface area or area of the surface is the integral 2 pi y ds, or the integral 2 pi y square root of the derivative of x with respect to t to the second plus the derivative of y with respect to t to the second, and so on. But what is this object? Before using technology, try to write down everything on a piece of paper. You need to feel comfortable about these types of computations. So in this scenario, we have x equals to 2 cosine theta minus cosine 2 theta, and y is 2 sine theta minus sine 2 theta. It means that x and y both depends on theta. Whatever make changes to theta has an effect on x and y. So what you're going to do, you're basically going to pre-calculus. You're going to plug in different values for your theta and evaluate your x and y. So take a look. There's a piece of paper here. Make sure you're following what we're doing here. So if theta is equal to 0, my x, I just plug in 0 here. My x becomes 1 and my y becomes 0. So it says, hey, this is your object you're looking at. It says when theta is equal to 0, my x is 1, my y is 0. What if I plug in pi over 4? If I plug in pi over 4, my x becomes about 1.41 and my y is 0.41. I just plug pi over 4 here and here to find my x and y. So this is my 1, this is my 2, 1 and 2, negative 1, negative 2, negative 1, negative 2, just to scale it a little bit. So my x is 1.41 and my y is 0.41, just about here. Next theta or next parameter. If it's t, you're going to use different values for your t. Pi over 3 gives me 1.5 and 0.87. 1.5 and 0.87. Next value, if I plug in, for example, pi over 2, I get 1 and 2. 1 and 2. If I plug in very good, more angles, if you have time, I highly encourage you to plug in different values. If I plug in pi, I get -3 and 0. So -3 and 0. So it means that I need more points in between. -3 and 0. So again, if you have time, you can plug in more values and you see the behavior as well. And again, continue if you have time. Well, I highly encourage you to do that. Once you feel comfortable with one parametric objects like this, the rest of them should be easy for you. If I plug in, for example, 2 pi, I get 1 and 0 back. 1 and 0 back. So again, by plugging more values, you see the object behaves like this. So let me make sure my points are here. Some of them are negative, some of them are positive. Remember how we used plug-in values for our theta and computing x and y. The behavior of your almost object. So this is your curve, and